Hello friends, myself Dhruv Malaiya from VIT University Chennai campus. I am here in front of you to present the design of cantilever beam. Going for design, first let us learn some basics. A building consists of different members like slab, beam, column, etc. Beam is a horizontal member which is designed to carry different type of loads coming from different directions. These type of loads may be vertical load, horizontal load or shear load. Beam can be used for different other members also like bridges, trusses, etc. Type of beam on the basis of supports. First, simply supported beam. Both the ends of the beam are supported by some supports. And second is cantilever. Its one end is only supported, and its second case is one end is supported, other end is not supported, but some other support is provided between the length. For continuous beam, number of supports are provided for the whole span. Effective span, that is L effective, it is required during the design of beams. For simply supported beam, L effective equals to minimum of length plus depth or length plus width. For cantilever beam, L effective equals to length plus depth by 2, whereas for second case, length plus width by 2. Here width equals to width of column. For continuous, for one case only, width support is smaller than 1 by 12, then L effective equals to minimum of length plus depth, or second is length plus width. After that, type of beam on the basis of reinforcement. Here we have singly reinforced section and doubly reinforced section. Here you can see that we have a beam with depth B and width B. Here lower zone is known as tension zone, whereas upper zone is known as compression zone. For singly reinforced section, only reinforcement is provided in bottom zone, whereas for doubly reinforced section, reinforcement is provided in bottom zone also and top zone also, that is in tension zone also and in compression zone also. After that, we have three more types of cases: balanced reinforced section, over reinforced section and under reinforced section. Here, if the neutral axis maximum depth is equal to the neutral axis depth according to our design, then we have balanced reinforced section. Whereas for over reinforced section, if the maximum neutral axis depth is smaller than the neutral axis depth calculated according to our design, then that will be over reinforced section. And for under reinforced section, if the maximum neutral axis depth is greater than the neutral axis calculated according to our design, then that section is known as under reinforced section. For calculating the XU max, we have formula based on the different type of grade of steels. Like for 250 we can use 0.53, for 415 we can use 0.48, for 500 we can use 0.46. Let us come to an example. Design a cantilever beam of clear span 2 meter supported by a column of 500, 500 mm. Beam is supported dead load of 5 kN per meter excluding self weight and imposed load of 8 kN per meter, taking F equals to 415 and M20 exposure condition is severe. Here I have described all the things which are given. We are here assuming the width of the beam equals to 250 mm. Here you can see that we have to first calculate the L effective, which is, as we have earlier studied the formula, which is clear span plus column width equals to 2.5 meter. For cantilever beam, we have a formula like L effective by depth equals to 12. For here we are taking modification factor like L effective by depth equals to 12 into modification factor. We are taking modification factor equals to 0.75. By putting the value of L effective and 12.5 into the modification factor, we can get the value of depth of beam, that is 277.8. Here we have to calculate the D effective, that is cover depth. Here we can find the depth of cover equals to nominal cover plus stirrups plus diameter of main bar by 2. Like here we are having nominal cover equals to 45 and we are taking stirrups diameter equals to 10 and diameter of main bar equals to 25 mm. After that we can calculate the D dash. For calculating the overall depth, we have to do the addition of depth plus cover, that is d plus d dash, we will get this value. We are taking it as a whole value like 400. From here we will minus the cover and we will get the value of d effective, that is 0.3345. After that we have to calculate the self weight. As we all know that the self weight formula is B into D into density of concrete. On the basis of that we calculated the value is 2.5. Dead load is given, live load is given, therefore the total load will be 15.5. and for calculating factor load we multiplied the dead load by 1.5, so the total value is 23.25. and for calculating the moment in beam, that is the moment which can be carried, which is carrying by the beam, is WL square by 2, that is the value is 72.65, and the shear in beam equals to WL. These two formula are especially for cantilever beam. And for calculating the MU limiting, that is formula is 0.36 FCK into XU limiting into B into D minus 0.416 into XU limiting. After keeping all the values we will find this value. By comparing this value MU limiting with the MU as we have calculated earlier, here our MU is 72.65 and our MU limiting is 77.33. So this shows that the maximum limiting value of carrying capacity of beam is greater than the load coming on the beam. So hence our beam is safe. So we have to provide only single reinforcement. That is, we will provide the reinforcement in tension zone only. Now we are calculating for steel. For calculating steel we have other formula like MU equals to 0.87 F by AST into D minus 0.42 XU. After putting all the values and cross multiplying, we will get the AST required equals to 2160.92. Now we are calculating number of bars. For number of bars we are using formula AST required by area of 1 bar, that is 4.40, but we have to take some whole value of number of bars, so we are considering it as 5. So on again calculating according to the number of bars we have provided 5, then we will get the reinforcement equals to 2453.12, that is greater than the AST required. That means AST provided is greater than AST required, hence we can provide 5 number of bars. Now we are calculating percentage of steel for checking shear. Here the percentage of steel equals to 100 into AST upon map BD. Here we will get the value of 2.86. After that we are applying check for shear, like we have formula for tau V, that is VU upon map BD. From that we will get 0.07 and tau C equals to 0.82 and tau C max equals to 2.8. The value of tau C and tau C max we can calculate from the table of IS code on the basis of grade of concrete provided. Here we have to get the tau C should not be greater than tau V, but here we are getting tau C is greater than tau V max. If this condition occurs, then we have to provide minimum reinforcement. Whether if tau C is smaller than tau C max, then we have to provide vertical stirrups, but here we have to provide at least some minimum shear reinforcement. For providing minimum shear reinforcement, again we are having formula which is according to the IS code. Here we are putting the ASV B, we have to calculate SV, and 0.4 by 0.87 into F5. After putting all the values we can find the spacing between the vertical stirrups, that is our value is 362.8. After that we have to check whether our spacing is whether our spacing is correct or not. Here we are again having some considerations given according to the IS code, that is first should be 300, second is 0.75 into D, and third is our calculated spacing. From our 3 equations we have to take the minimum value. So our minimum value is according to the 0.75 into D. After that we have to check the deflection, whether due to the load our beam is deflecting or not. So actual actual ratio equals to span upon depth equals to span equals to 2500 divided by depth equals to d effective, and it is 334.5. According to that, our value is 7.47. but here required span upon depth ratio is 12 into modification factor. As earlier we have take modification factor equals to 0.7, so on multiplying that with 12 we get 9. So our actual span upon depth ratio is smaller than required span upon depth ratio, hence our section is safe and it will not get deflect. Thank you.